All right, so we're talking now a little bit about logs. Now, I wonder how many people last year really understood why we have logs. Why are logs useful? You have a guess? Yeah, go for it.
Well, I think of it as like the backwards way of solving exponents and stuff.
So certainly logs are the inverse of exponents, like multiplication and division are opposites, addition and subtraction are opposites, exponent and logs are opposite. We will get there a little bit later today and next couple of days. But the biggest reason we have a log is that it helps us write really big numbers as smaller numbers. Let me give you an example. So we say a log. Imagine I said log of 1,000. Log of 1,000. What we are saying here is the following. And let's say I put a base 10 here. I'll explain why it's not necessary in a second, but imagine I have that. This is read. In words, this is saying this. 10 raised to what power equals 1,000. This is what this in words means this. 10 raised to what power equals 1,000. So if you have to think about that, 10 raised to what power gives me 1,000? I hope most people are confident enough to say what?
1. No.
10 raised to what power gives me 1,000?
100. 3.
Maybe 10 raised to the third power?
Yes.
Right? 10 times 10 is 100. 100 times 10 is 1,000. Right? So this would equal 3. This would equal 3. How did we do this? Oh boy. What we did is we said 10 raised to the third power, 10 raised to the third power equals 1,000. 10 raised to the third power gives me 1,000. This is what we mean when we say log of a number. We're meaning that number, the base, we call this the base. The base raised to what power gives me, let's call this the argument. So the base, 10, raised to what power, that's what I'm solving for, equals or gives me the argument, 1,000. So, if, by way of example, we were doing problem 19 on the homework, if we're doing problem 19 on the homework, which says log base 7 of 49, log base 7, 49, what this is asking us is, in words, we already know the answer, probably a lot of folks, 7 raised to what power equals 49. 7 raised to what power equals 49? We all can say 2. The answer to this question, answer to number 19 is 2. Questions on that? All right, so why is a log useful? Well, notice what has happened. Over here we have the number 1,000. Over here we had the number 1,000. When I took the log base 10 of 1,000, the answer was 3. So instead of writing 1,000, I could really basically say this is log 1,000 equals 3, because 10 raised to the third power gives me 1,000. So instead of writing 1,000, or 1,000 is an easy number. Imagine if this was 20 million or 100 million. Rather than writing out 100 million, I could do log of 100 million and I'd get like 20 or something. Because 10 raised to what power gives me 100 million. Now, let's identify a couple of things. Sometimes they will not write the base. They might just write this. if there is no base written, if no base written, we assume it is 10. Gotta know this. If there's no base written, we assume it is 10.
Assume.
Hmm?
You say assume.
Assume. If there's no base written, we assume it is 10. Now, if they want to make the base 3, they'll put a 3 there. If they want to make the base 8, they'll put an 8 there. If they want the base to be 20, they'll put 20 there. Whatever they want to do. Other thing we have is what we call the natural log. Natural log, which is ln of whatever, a number. Let's call it ln of 6.85. I just picked a random number. The number means nothing that's there. Notice this looks a little bit different than this. When you see this, it's called natural log, and the base is e, which is a number that equals 2.513, I think. And there's many more numbers, but I'll stop it there. So these two things are the same. What I'm about to write these are the same. These two things are the same. Log base e is the same as ln. Nobody writes this. No one writes this.
No one.
The convention is you write this. These are the same thing. Nobody writes this. You see my point here, Josh? So, we need to use this notation, but these mean the same thing. All right. Now we have an interesting question that I will be done talking. I'm going to do number 23 on the homework. I like to do number 23 on the homework.
That's 24.
Hmm? No, I want to do 23.
Oh.
I think so.
23 says the following. 5 raised to the negative 2 equals 1 over 25. Okay, this is a true statement. Remember, negative power, you come downstairs. But they're asking us write this in the log form. Daniel?
Log 1 plus. Oh, log of 5
Log of 5. So this is the base. So this number.
over
And then what do you want in the argument?
the 1 over 1. 1.
Okay. Equals what?
Negative
Negative 2. Because we're saying 5 raised to the negative 2 power gives me 1 over 25. So just like a second ago I did this example. Second ago we did this. We said what is this number? Well, 7 raised to what power gives 49? 2. 5 raised to the negative 2 power gives me 1 over 25. That is all I have. This is due Wednesday. The bottom asks you to draw some graphs. The graphs are conveniently 1, 2, 3. If you want to draw them right now, they're right there for you. You can get those easy points on the homework. And I'm going to come around and pick up all the stuff that you have to give me today. So, Lucia, we can stop the recording if you don't mind. So I should be picking up journals and surveys or autographing new demerit cards.